the format for a quadratic of a parabola. And in order for us to find the equation that these 3 points will sit on that parabola, we have to find A, B, and C. So we take each one of these points, string them down, take the X and the Y, and substitute it in there so that it leaves our A, B, and C. We're going to get 3 equations with 3 variables. And then we took the shortcut, if you wanted to, and put it in your matrix. Sometimes it was easier if you substituted in. A little back substitution kind of worked also. So sometimes it was easier if you substituted in rather than did your matrix. What happens in your matrix for this one is, don't forget your matrix is reduced row echelon. Your constant has to come on the right-hand side. So all of these have to be on this side. So you might want to write this over. C equals 0. 4a plus 2b plus c equals negative 2. 16a plus 4b plus c equals 0. Your constant has to be on the right-hand side. Go into your matrix. How many of you used a matrix to solve? About half? About half of you did? Was it easier?
Yeah.
Yeah?
Yeah, I think so.
Yeah, once you get the equations. I mean, some of them weren't too bad, like this one eliminated C right away, so you only really had to combine one set.
Yeah, the ones where it's just like one term immediately, like number 2 where it's 3 equals C or something, those are easier.
Yeah, and you can still absolutely use a matrix for this. And just make sure you fill your spaces with zeros. Once you find your A, B, and C, plug it back into your format. This is what was bothering you, Joey?
Yeah.
What to do with it?
I just didn't understand, like, when I was doing the system equations part, I would get lost on where to put it, but I get it now, how you just gotta plug it back in. This is so interesting.
It's okay. The one thing you notice when we do quadratics, we never have decimals in our quadratics. We have fractions, but no decimals. So if you come out with decimals in your matrix, just go to math, fraction, flip it back to a fraction. Because we don't really put decimals in our math equations. And you do need the plus 0?
No, you do not.
Does it hurt if you put it there? No. Questions? Ask me if you have a question. Otherwise, I'm just going to move on. Good?
Yeah.
Okay. Next one. They're all basically the same.
Wait, just one.
Circles.
Yes.
Are we allowed to use decimals? Is one right answer?
Nope. Put it to a fraction.
Okay. On your test as well?
Yep. Because whenever we use a quadratic, do we ever have a decimal? It's harder for us to factor. We can't factor a decimal.
Yeah.
Right? So it's like 0.5. I can't really factor 0.5. 1/2, I can do 1/4 times 1/4, but I can't not 0.5.
You always want to have that the y equation.
Yes, that's your goal. That's your end result, to give me the equation that fits these 3 points. Again, and if it helps you, if you like to separate like your x and your y so that you remember where your y is, because you're doing a lot of substitution, what happens, the biggest mistake I see here is not putting the y in. Coming out with an expression but not have the y in there. The circle, the y, it's 0 equal, and the x and the y are all in your equation. But this one's a little different. Remember, you're going to have to switch these around if it's going to go in your matrix. Okay, your constant has to be on your right. And again, like Joey said too, if C is 3, you eliminated one of your variables. So now you have 2 equations, 2 variables. Once you solve for one, you back solve into the other one. You back solve into the other one.
So for the matrix, if we're doing that on a test or something, is all the work you want to see plugging it into the original equation, the A, B, C's or whatever, and the end equation?
Yes.
Okay.
Yes. What I would like, actually, is for you to show me your matrix. You know how to print your matrix out?
Just redraw it out?
No, like,
Oh, with the one.
Here's my problem with this. I can see your equations, but I can't see what you put in your matrix.
Right.
Now, if you put this in without the zeros, or something happens and it does, or you put a positive instead of a negative, I don't see that at all. Neither do you. So in your matrix, if you want to print out your matrix, you just do this. Second matrix, go to A, just go like this. Just copy that down for me.
Just copy
Yeah, because what happens for both you and me, like say for instance you forgot a -1 and you just put a 1.
it. Yeah.
Your answer's wrong. But if
No,
it's just simply that you forgot the -1, I don't want to take off your full credit. I don't know what you put in there.
Okay.
I'll see your 3 equations. You'll get credit for your equations, but then I'll say, something went wrong. What'd you put in your matrix? And you'll say, I don't know. I put it in my matrix. It's gone.
Okay.
So you're just asking if we do the matrix, just write down what's in the...
Print it out for me. It's for your benefit too. For your benefit too. You make one mistake on this matrix, and of course your answer is different. But would I want to take off a lot of points for that? No, not if I see that it just went in as a positive, not a negative. That's the problem about using the calculator. And even for your own calculator, you have 5 problems in a row. If you put in problem 2 and it didn't work out, and you're on problem 4, you don't know what you had in there. You might have done everything fine, you just had the wrong number in there. And that happens a lot, trust me. Again, build your 3 statements. Now this one, you might really like to use the matrix for this. You have 3 statements with 3 full variables. So to solve this, you're going to take 2. We did this yesterday. We took 2, combined them, took another 2, combined them. Then we combined those 2, then we back solved. Was it bad? It wasn't too bad because the numbers we were able to eliminate. I eliminated the C, back solved, eliminated the B, and then solved for A. And back solved. That choice is up to you. But you do have to know how to do these algebraically as well. It's just the systems of equations. And because you're a y equal, put it in your calc. Make sure they check.
So say we were to like make a mistake as to not square like the 3 in the second equation, but we did like the entire question right.
Well, that's a half a point. I would that point is that's a mathematical mistake. What would bother me more is a conceptual mistake. That if you didn't square any of these, if you didn't square them, then you made a conceptual mistake. What happened to your x squared? But if you just didn't square 1, it's just like a computation mistake. If this was 10 points, I'd take off like half a point. I think I'm pretty fair when it comes to grading this. It takes me a very long time to grade these, and that's why I ask if you use your calculator, show me your matrix. Because if you go through the steps and you get up to here, and then you give me your ABC, if your ABC is off, I say, what happened here? I know you knew those. Did I think maybe that you put your constants here and not there? I don't know. I don't know what you did.
So when we test on this, like, are we going to specifically have to, like, do one way, or can we do either? Like,
Probably a curve fitting, you can use your matrix. Because we did the other ones by hand before the break, so that's why I kind of wanted to separate them. I had to do them algebraically, now I just have to do them in the matrix. Okay?
When is the test or quiz going to be on this?
Probably next week. We still got to do some things today.
Are they hard?
Not at all. I want you to ignore all my squares on my A. Don't ask me why. I was square crazy here. A's obviously don't get squared here. It's habit. And then I stopped doing it. So when I did this before the break. I must have been talking or on the phone or something. I wasn't paying attention. And so finally when I realized it when I came down here, so just take away my squares. And again, you got 3 good equations in this. Using your matrix is nice for this. It's not dropping one that easily. So, you know, it's a little bit more work if you're going to solve it by hand. And let's get to the answers. There you go. It's great to put in your calculator, go to the table, and make sure your 3 points are there. It's self-checking. The ones that are a little tougher, I think, are the circle ones. Not so much that they're tough, but first of all, you're really not used to looking at your circle in that format, and these are all 0 equals. So you have to take this whole set of 0 equals and make sure you put it at the end. So instead of leaving that first like this, set it to this way. Just set the 0 to that side. Keep the 0 on that side. You don't want the 0 first because your constant has to be last. So set it to that. You can set your parabola to the same thing. Set it equal to y, ax squared plus bx plus c equals y. Set it first. That one's a nice back solve because you can take the 0, put it into the third one, then solve for d, put them both into the second one.
Yeah, I did that. I had the equations right there. I did this one in my matrix, but I
Okay.
got wrong.
See, case in point, I can't tell what you put in your matrix.
Can we go over it? Can you do it in the calculator?
Okay, do you have these equations?
I have those equations.
All right, so you're going to have to fill this in. You're going to have to set it up DEF and get these. These guys, you got to subtract. Your constants have to be last.
And would you do all 6 spots because it's X, Y, D, E?
No, you're just doing whatever's in your equations right here.
Just whatever's in your equation.
You're going to combine these pieces.
Oh, okay.
And then you're going to combine them with your other side. So this guy is going to be 5D plus 5E plus F equals negative 50. Your constant has to go on the other side.
Okay.
This guy's going to be 10D, put
Plus
0,
F.
no E,
No F?
F equals negative 100.
Okay.
These have no zeros here. So you're looking at a matrix like this, 0, 0, 1, 0, 5, 5, 1, negative 50, 10, 0, 1, negative 100.
Okay.
Try that and see if you get that answer. And when you do this, that's the matrix I want to see. This is perfect case in point. You went all that way. You got the right 3 equations. You just didn't put it in your calc right. So if I see what your matrix is, I could say, well, your constant is not on the right-hand side. Take a point off. Versus take 2 points off because your whole answer is wrong.
For these questions on like a test or quiz, we could just back solve instead of using matrix.
Absolutely. I would use whatever is easiest, whichever way you prefer. You don't have to use a matrix.
And it doesn't have to be consistent for each problem.
Nope, not at all. Like I said, here I would definitely back solve. Absolutely. Back solve, look how much easier this is. To change and put it into the same format took you longer than to back solve.
Yeah, I got it.
Yeah. But on some of them where they have all 3, just move the constant to the other side and you got all 3 equations.
Would it be...
Go ahead.
Is it okay for you to go straight from the points to the equations that you have? Like,
If you can do that, yeah.
that's fine.
That's fine, but don't forget, if you mess this up in here, I'm not going to see it.
Yeah.
Now, see, that's a problem with not showing you that part.
Well, yeah,
So
but
that's
like,
it.
I mean, like on the homework.
Yeah. Of course, on the test, I need more work, but on the homework, yeah, no problem. Joey, works for you now?
What happens if they're all 0? What is that?
You can't be all 0. Then you would have no equation.
No solution or no equation?
You'd have no equation for this. And A can't be 0 because you wouldn't have a quadratic.
Oh, yeah.
You could have B be 0 or C be 0, but you can't have all 3. And
Because
you
then
can't
it
have A.
doesn't make the thing.
It wouldn't make a parabola. The other 2 could be 0, but not all 3. And definitely not A either. Okay? this one. And notice the circle ones are not so bad either. They're not so bad for this because if you think about a circle, most of the circle comes like in between your graphs. So we got to find the points that are decent points. So they're kind of falling like 6, 0, 3, 0, 0, -3. They're falling on your axis, most of them. So they got a lot of zeros in them. Because otherwise your circles, if you think about it, these points are easier to find. But what about these? They're not so easy. Every once in a while we hit one that crosses perfect, but most of them don't. So again, I would back solve this without putting this into my calc and set it up. Good? Questions? Then, did you see what we did?
Yeah.
Now, the rule is when you add and subtract, your matrix has to be the same order. We call it order or dimension. It has to be the same order. The entries have to kind of correspond. This is not a mistake. This says if and only if their corresponding entries are equal. The order of them, not the entry themselves, but the order of them. So this is a 2 by 3. To add or subtract, this also has to be a 2 by 3. Now, when you add and subtract them, it's like placing one right on top of the other. It's as if I took this and combined it to this one. So I'm just adding my corresponding elements. So 1 plus 0 is a 1. 1 plus 0 here is a 1. -2 plus 3 is a 1. Your corresponding elements. 1 plus a -1, 0. 2 plus 2, 4.
Wait, what?
We're adding your corresponding elements.
0 plus 1 was the first one?
Yep.
And where does
The
that
first
go?
element, first element. Second one in the first row, second one in the first row. And we're going to make the same thing, a 2 by 3.
Oh, okay.
We're going to make the same one as if we took this guy and put it on top of this and combine those terms in place.
Okay.
And a 3 and a 1, a 4. We make a matrix with a bracket around it. It has a big bracket like this. And we end up with the same dimensions, the same order as our two other ones. We can subtract these as well. Now, it doesn't matter what order we add them in, but it does matter what order we subtract them in. If we do A minus B, then this is 0 minus 1, and so forth. If we do B minus A, then it's 1 minus 0. See the difference? Order will matter on your subtract, but not on your add. Now, can you do these on your calculators? Absolutely. If we pull up your matrix, and it'll write right over these guys. You don't have to clear your calcs out. As soon as you say a new dimension in this, 2 by 3, it gives you whatever was there, but it reorganizes it 2 by 3.
Right.
So all you have to do is put your entries right over this. So let's enter the first one. And just kind of eyeball it, make sure you have your right entries in. Again, the problem with using a calc is you don't know if you put it in right. Don't forget to quit. If you don't quit, it won't hold it there. Go to the second one. Well, it will hold it, but it won't let you do any operations on it. Let's go down to B, 2 by 3. Let's put B in.
This one's screaming.
I don't know. Who knows? But I will tell you, they're moving the cafeteria entrance.
Oh,
They are.
next year or
Next week.
Oh,
Next week.
Oh.
It's the power of the people.
that's good.
Yes. And today there was a big fight going on out there.
Oh, when? What time?
Period
It's like third
6.
grade.
No,
It was earlier.
It was
so I
before-
had
it was earlier.
senior.
My teacher was talking about it.
Period 4.
How did you get it on
Period, it
videotape?
was period 4.
Should have recorded it for
So, in order to get here, guys,
Yeah.
you're going to now come back. If I want to do this on my calculator,
Yeah.
I have to make the statement.
Yeah.
A plus
No.
B.
Really?
You have to go to your matrix and get your matrix symbol, A plus B. Now you see
No
your
way.
resulting matrix. You can also do A minus B. You can also do B minus A. Joe. Okay? It'll do as long as your dimensions are the same. Now, watch what happens. Just let me change this for a second. I'm going to go change my first one and do a 3 by 3.
What happens when you do A times B? Oh, no.
Okay, I'm going to do a 3 by 3. It doesn't matter that that's 0 blocking. I'll just enter some in here and make you happy. Okay. 3 by 3. Now watch. If I say add these together, God bless you, it's going to say, whoops, mismatch. My dimension is mismatched. They're not the same order. Don't forget I changed them. Changed it to be 3 by 3. So they have to be the same order for you to be able to add them. Okay? And subtract works the same way. Now, sometimes we have what we call the 2 different orders. We just saw that you cannot add 2 different orders. This is undefined. Can't do this. This is a 2 by 3 versus a 3 by 2. Can't add those. All right. So the next part we look at is called scalar multiplication. When you multiply a matrix by a constant number, a real number, it has to be a real number, it can be a fraction, it can be a decimal, it can be negative, it just has to be real, not imaginary. You multiply every entry in that matrix by that number. So if I want to do 3a, I'm going to multiply every element by 3 and make a new matrix. I'm not going to change the dimension of this at all. I'm just going in place, multiplying everybody by 3. Right, you multiply everybody by 3.
I think this one's easier.
Then you come here, you take this guy, you subtract B. They've got to be the same dimension. This is where they got to be the same, and it is. So, element per element. 6 minus 2, 4. 6 minus 0, 6. 12 minus 0,
I think it's
12. Good. What is negative 9 minus 1? Good. Negative 9 minus 1.
Oh, negative 2. That's
Okay.
math.
0 minus negative 4.
4.
4. Negative 3 minus 3. Negative 6. 6 minus negative 1. Simple math, Joe.
Oh.
7. 3 minus 3.
It's going to be 1, 4, 0.
6 minus 2. Okay, now, you could put this in your A matrix, you could put this in your B matrix, and then make the statement. Minus B. And that will give us that matrix. Make sure when you put your A and your B that you go back to your matrix and you use your matrix letters. No, we just did it with the add, so it'll work the same exact way. And I'm okay with you doing this with your calculators. The only thing that we have to do by hand is multiply, which we'll get to in a minute. Now, sometimes you have to solve for x and find me what resulting matrix should be. So you just take your problem and you solve for x first. You say 3x plus a equals b. These represent matrix, a matrix. So I get 3x by itself, subtract a.
X equals a minus a over 3.
Yeah, and divide by 3. Now what you might want to do is pull out the 3 in front of it like this. Or you can still do it in your calculator. 1/3 PV parentheses red matrix B minus A divided by 3. You can do that. You can probably do this. It's easier. So,
Either multiplier or an addition.
well, what is this over here?
Divide.
What's
and,
this?
Oh, subtraction.
Subtract.
And multiply.
Hang on. You got to do the subtract first. You got to do from B to A.
Oh,
So, what is negative 3 minus 1?
-5.
Negative 4.
6.
4 minus a negative 2. 6. 2 minus 0. 1 minus 3. Then take this and multiply it by 1/3. Can you get fractions? Absolutely. I would not bring this to a decimal. This would give you a 2. This would give you a 2/3 and a negative 2/3. When you do it in your calculator with your matrix, just go to math. The first thing it's on is fraction and hit enter. And it brings your decimals to fractions. If it doesn't do this for radicals, I mean, if I gave you a radical in there, you'd have to do that one by hand. I wouldn't give you a radical in there. But, you know, you could get a radical. No, actually, you could. You could get a radical because it's a real number. But we wouldn't do that. Okay. Have time for the multiply?
That's close one.
All right.
Wait.
Now, I need your undivided attention for a multiply.
You need
This is-
multiply.
This is the only one that I require you to do by hand. You can check it on your calculator, but anytime we multiply, I need you to be able to do these by hand. And the first thing we do is pull out the order of both of these. This is a 3 by 2, and right next to it, this is a 2 by 2. The innermost ones have to be the same, or you can't multiply these. In other words, if I did a 3 by 2 times a 3 by 2, 3 by 2 by 3 by 2, these would not be the same. Even though they're the same exact elements in there, the same number, it doesn't multiply. So the middle two have to be the same. The resulting matrix is a 3 by 2. That's what's left on the outside. You got your inner ones the same, outside resulting matrix.
This one,
Yes.
if it was like 3 by 2 times 2 by 4, the result would be a 3 by 4.
Yep. So now, how we're going to multiply is this. Let me show you first. We're going to take each row and each corresponding element of each column. So we're going to multiply, if you just look for a second, -1 times -3, then 3 times -4. We didn't complete the row yet because we have more columns. Then we're going to do this to this column. Once we do that, we're done with that row. We go on to the next row. Now, I'm going to multiply this whole thing out, and I'll show you the reason why at the end. I know you can do this in your head, but I'm going to show you why I do this out. And you can do this with me. -1 times -3. No, I want you to write it out. I'll show you why in the end. 3 times -4 plus, and you put pluses in between them. 3 times -4. Now, we're at the end of that column. Just put a little dotted line. The next column, same row, next column. -1 times 2 plus, take the next element, 3 times 1. So we did that whole first row, element for element. Okay? Second row, 4 times -3. Plus, -2 times -4. We're jumping to the next column, same row. 4 times 2 plus -2 times 1. see a pattern developing here?
What happens with the parentheses?
Oh yes, the parentheses there. Next row, last row. 5 times negative 3 plus 0 times negative 4.
I don't see it.
Have we looked up? Okay, guys, let me just do this last one. 0 times 2 plus 0 times 1. Look at these down here. See them?
How is it 0 times? Is it 5 times 6?
Oh, did I mess this up? 5 times 6, 5 times 7. Ah, thank you. Now watch. See this pattern here? Negative 1.
Mr. Martin, please call Ms. Dan at extension
We'll finish this tomorrow.
35525. Mr. Martin, please call
First
Ms.
homework,
Dan at
do
extension
everything but the last
35525.
page.
You, the last page, everything
For
but the last
homework, do everything but the last page.